All right, let's look at another integration by parts formula. So this function here looks like we have a polynomial, and this other function that's being multiplied to it is a logarithm function. So which one should we select as our choice for u? Logarithm is the number one selection there, so that's definitely the one we'd want to pick there for our u. And the reason we want to do that is, remember, the rest of this ends up being our dv. On this side, we end up taking the derivative. We want to find the derivative here, which is easy when you do log. It would just be that du equals derivative at natural log's 1 over x dx here. Whereas if we had that as our other one over here, if we had natural log, remember here we're doing what's our antiderivative. That's not so easy. I can't tell you what the antiderivative of natural log x is. That is not 1 over x, and in fact, I'm not even sure what that is. So that's why log is number one selection, is because it has an easy derivative, but not an easy antiderivative. So that means whatever was remaining over here becomes our dv. So the rest of that was x to the fourth, and then our dx along with that. So what is that antiderivative? That's easy. That's just using our power rule for antiderivative. So we want to go up 1, x to the fifth. We need the reciprocal in front, and that's our antiderivative. So 1/5 x to the fifth. So now if we write this out in the integration by parts formula, we should have it. So we want to write uv. So u here is natural log x. Our v is 1/5 x to the fifth minus the integral of v, which is the same thing, 1/5 x to the fifth du. Our du here is 1 over x dx. All right, so if we now simplify this, this should give us the antiderivative here. So on the first part here, there's nothing really to do. Usually constants and polynomials are written before other functions, so I'm just going to switch the order there. Minus, all right, before we do this integral, let's do a little simplifying here. 1, that's a constant that can be pulled out. Also, these two terms should be able to be combined into 1. If we get x to the fifth over x, that should just simplify to x to the fourth for our integral. So this would be minus 1/5 the integral of x to the fourth dx. All right, so now let's find that antiderivative. Going up a power here should be our same one we basically found before. That's going to be x to the fifth with the reciprocal of 1/5 in front, plus a possible constant. And now for our final answer, just combine those two fractions together into 1 over 25 x to the fifth plus c. There's our antiderivative using integration by parts. All right, let's have you try this one. Why don't you pause the video and see what you come up with first. Remember, your first choice, you got to figure out, we got these two functions here. Which one is going to be your selection for you? All right, let's see how you did here. So with our polynomial and exponential, polynomials are higher on our list than exponentials, so that should have been our choice for you. That's an easy derivative. Derivative of 2x is just 2 right here. That means the remaining stuff, our e to the 3x dx is our dv. Remember here we're doing antiderivative here. That one's a little bit harder here. Make sure you had antiderivative being 1/3 e to the 3x. That one, if you weren't able to do that, that's almost like kind of doing a substitution there. If you couldn't integrate e to the 3x in your head, maybe think, okay, if I substitute 3x in here, my derivative would be 3 dx. And so now if you made that substitution, this is e to the u, but then our substitution for dx there would be 1/3 du. That's where that 1/3 comes from. And then that just ends up being 1/3 e to the u as our antiderivative, and then if you substitute back in, that's becomes that 3x. So you should have had a 1/3 there as well. So make sure you had that. So now if you put everything in place here, here's our u, v minus the integral of v du here. Couple things we can do. These two constants could be combined into 2/3. There's also a 1/3 into 2 here can be pulled out as a 2/3. Now we got that same integral over here, which becomes 1/3 e to the x plus c using substitution. If you combine those two fractions together, now you end up getting 2/9. So that would have been the answer right there. One thing with this answer too, you may see this written on the test another way. If there's some like stuff here, like a 2 and an e to the 3x, it's possible that they may factor that out in the answer. So you might see it something like that, and then have the remaining stuff in like a parentheses or something where it'd be like 1/3 x minus 1/9 or something like that plus c. So I won't be surprised if you saw like a factored version of that answer or something. Just a possibility. All right, let's do one more here. Let's try one with an inverse trig one here. So the only thing here we see, this is an inverse trig, and on our list of choices for u, that's number 2. And there's no logarithms in our problem, so that's definitely here our choice for our u here. So u is going to be our inverse tangent, or tan, because, and the reason we want that is we should know these derivatives. The antiderivative are very hard to find, kind of like natural log, which is why we want it on the derivative side, not the antiderivative side. Derivative of inverse tangent, arctangent, that's the 1/1 plus x squared dx there. All right, that means our remaining stuff is our dv here. So the only thing left, there was no function, so it's just our dv equals dx, and this is just like a polynomial basically on this side. Antiderivative of the other side then would just be x. All right, so now if we put it into our integration by parts formula, we have u, which is our arctangent, times our v, which is x, minus the integral of v, which is our x again, du, which is all this stuff. Okay, so on the first part of this, you can't really combine those. We can't put these two x's together as x squared because it's our tangent of that. So most of the time you just see that written as x times inverse tangent or arctangent of x. All right, on the other one, how do we now integrate that? Well, that becomes a little bit harder here to do. That's not an easy one. What we can do though, I think on this one, is to look at doing a substitution. So not only does this problem have integration by parts, I think we're also going to have to do substitution to do the second integral. If we put u equal to all this stuff in the denominator, I think this is going to come out here because derivative of that would be 2x dx. I see over here that we have a x dx. So here's our x dx. I think if we just move that 2 over by dividing, we can now substitute in the rest of that. So this new substituted integral would be minus, I'm going to pull that 1/2 out. This would become now 1 over u, because all this is our u here, and then the x dx becomes our 1/2 du, which I already put the 1/2 in there. That antiderivative we know, that's going to be natural log of whatever we are doing. And it'd be absolute value in this case when we do that. So now substitute back in for u, and we got our answer here. So it'd be x times the arctangent of x minus 1/2 natural log. If we substitute back in what we put for u, it'd be 1 plus x squared plus our constant. There's our solution right there. One other thing you may see on a problem like this, I won't be surprised if like on a test, this can't really do anything with this, but since this x is being squared, no matter what number we put in there, negative, positive, if we square it, it's going to become positive. So the absolute value sign is not really needed in this one. So it could just be written as 1 plus x squared plus c. Also, if we have this in front, remember we can use our log properties and make that an exponent. And we know exponent of 1/2, you could also possibly see the same answer then written as the power of 1/2 is the same as square root, so you might see it written as natural log of square root of 1 plus x squared plus c. So I wouldn't be surprised if that type of thing would happen on the test. So just be able to manipulate and change stuff around a little bit to fit possible answers.